This is our second video on mean, and yesterday we learned that mean is an average, and we calculate that average, the mean, by getting the sum of the data and dividing it by the number of terms. So our goal today again is to find, compare, and interpret the mean of data by scoring 80% on a graded assignment. We're going to have an added focus today on outliers and how we sometimes need to interpret the mean and recognize that the outlier affects that mean. We're going to talk about this a lot more as we move in through chapter 9, but we're going to introduce that today. So again, mean is an average, and we can calculate that by getting the sum of the data and dividing it by the number of terms. So I've got a couple of examples right here, and just like yesterday, these are assignments you may complete with a calculator. So we're asked to find the mean of this data here. Now before we start, let's count how many items are in this data set. I count 1, 2, 3, 4, 5, 6, 7, 8. So I know once I get that sum, I'm going to divide it by 8. All right, so remember it's the sum divided by the number of data terms. So I'm going to use my calculator to add up these numbers, and I'm going to add carefully to make sure I get the sum. So 49 plus 62 plus 52 plus 54 plus 61 plus 70 plus 55 plus 53. And I got a total of 456. Now, as I added that, I feel like maybe I made a mistake, and I'm not sure. And so whenever I'm doing mean, specifically if I've got a large group of numbers, it's a good strategy to go back and just add it a second time. Make sure you've got it right. So let me go ahead and do that. And I did get 456. So I was accurate after all, but now I'm absolutely sure that I was accurate. I've got that total. I'm going to divide it by 8, and I'm going to get an actual mean of 57. All right, and that will be my correct answer there. So for number 2, a very similar type of question, except now we're dealing with some decimals. So we're going to go ahead and clear our calculator. Again, I'm going to count my terms. 1, 2, 3, 4, 5. Now I know my sum is going to be divided by 5. I'm going to go ahead and add this up. 7.2 plus 8.5 plus 7.0 plus 8.1 plus 6.7, and I got an answer of 37.5. And just to double check, that attention to precision is so important, I'm going to go ahead and clear that calculator and add that again. 7.2, 8.5, 7.0, 8.1, 6.7, and there I go. I did get that right. I'm interested in seeing what would happen if I added these terms and did not include the decimal for 7. Let me try that and see what happens. And you'll see I can absolutely drop that decimal point and just write the number 7 there, and that would certainly give me the correct answer. All right, so now I've got that. I'm going to divide that by 5. And sure enough, my average is 7.5. Now, this, even though yesterday we rounded up those batting averages, generally whenever you're finding the mean, you want to give the exact answer unless the directions specifically tell you to round it. There should be some logical reasoning if you're rounding money, where you'd round it to the nearest penny. But in most cases, unless the directions tell you to round it, you should just write the whole answer down, and that way you will be fine with that. All right, so let's move on. We're going to have a question that involves ponies. This is actually a picture of a Shetland pony. If you want to see a better picture of that and a second picture of that, you can go in the textbook in lesson 9.2 on mean. And what we're going to do is we're going to calculate mean with and without an outlier. So again, an outlier is data that's very different from most of the data. So for example, if we were to find the mean of the ages of people in our classroom, we all know there would be a ton of answers of 11 and 12 and maybe a 13 here or there. But then when you throw my age in there, that'll completely throw off our average. And so we want to be aware that my age would be an outlier. It's much, much higher than where most of the data falls. And that's going to be the case with this Shetland pony here. When I look at the heights of the Shetland ponies, and I'll zoom this in for you, you can see our heights are 40, 38, 37, 38, 39, 37, 40, 28, 42, and 40. That 28 is much shorter than most of the ponies. In fact, it's about a foot shorter than most of the ponies. So what we want to realize is that outlier, when I put it on this graph, look how far away it is from where the data cluster. So what we want to do is, in a situation where we're finding the average, sometimes it makes sense to not include that data because it's really not reflective of the data as a whole. So watch what happens when I calculate this data by adding up all the terms and dividing by 10. I get an answer of 37.9, and that's the average height of the ponies, which makes sense. It falls in here. But if you think about it, right here is a weird place to say that average because my data's clustering in this whole space here. And so we want to be aware that that outlier is bringing down our average, much like a student who gets a 0 on their homework. It really brings down their average. It's not really reflective of them as a whole, which is why we always want to do our work on time so our average truly reflects our ability. Now, if I redo this data, and you'll notice that they didn't include that 28 in there, and then only divided it by 9, because now there's only 9 terms, the average height is 39. Which falls right here, right smack in the middle of that cluster. And that makes a lot of sense. So when we're finding an outlier, or we notice an outlier in our data set, a lot of times that number might not be worth including because it really makes our data not reflective of the data on the whole. Tomorrow and the next day, we're going to be working on median and mode. And those are other measures of center that don't allow the outliers to affect it as much. So our next goal will be just to be able to identify an outlier and then talk about how it affects the mean. So if I was to go into a kennel and weigh all these dogs, you can see there's 1, 2, 3, 4, 5, 6, 7 dogs, and I see that those weights are 48, 50, 55, 60, 8, 37, and 50. You'll notice that that one dog that's a lot lighter than the others is definitely going to affect our mean. In fact, why don't we try finding the mean, including all the dogs, and then find the mean without that 8-pound dog. Let's see what happens. So we're going to go ahead and use our calculator again. We're going to add 48 plus 50 plus 55 plus 60 plus 8 plus 37 plus 50. And we get a total of 308. And then we'll divide that by 1, 2, 3, 4, 5, 6, 7. And if I divide that by 7, I get an average weight of each dog is 44 pounds. That's not very realistic because most of the dogs, weigh, in fact, almost all the dogs weigh more than 44 pounds. That's not really very reflective of where that data clusters. Now let's go back and redo this data, but now we're going to eliminate that 8. So we're just going to add up 48 plus 50 plus 55 plus 60 plus 37 plus 50. And when I get that total, it's only 300, but I'm dividing by only 6 now. And wow, that average bumped up. That mean really is a lot higher now. And so you can see that that outlier of 8 pounds really brought down the average quite a bit. So we want to make sure we're considering that whenever we're working with mean, that an outlier can certainly impact that data set. So here is one of our last 3 examples. This is a graph, and it shows visits to your website during the course of a week. And if I wanted to find the average number of visits per day, I'm going to add up 12, 16, 0, 8, 31, 28, and 17. And I want you to realize a couple people might think, well, we shouldn't include the 0. But the problem is, on day 3, there were no visits to the website. And so as a result, that is going to affect our average. All right, so we're going to go ahead and find out the average number of visits to the website. I'm going to add 12 plus 16 plus 0 plus 8 plus 31 plus 28 plus 17. And I got a total of 112. I'm going to divide that by the 7 days. And on average, there's about 16 visits per day. And you can see, obviously, days 3 and 4, where there were a lot fewer visits, really brought down the average. where on days 5 and 6, where there were a lot more visits, it brought up the average. I'm sure you'd be all interested in knowing what the average number of views I'm getting on my YouTube video. And the reason that there's been several questions that I've asked you about watching the videos is that I'm having 70, 80, 90 kids hand in their work, but only 40, 50 views on my videos. So I want to make sure that everyone's watching the videos, and that's probably why some of you are getting poor scores on your assignments, because if you're not watching the video in full or you're not watching the video at all, you're not getting the lesson that goes with it. So I appreciate those of you who have been watching the videos and participating. So here are 2 examples, and these are easy. I could even do these without my calculator because I can add these numbers in my head and know this is a total of 16 divided by 4, which means my mean is 4 emails sent per hour. And here, my magazine subscriptions, I can add this up in my head. 3 and 7 is 10, plus 6 is 16, plus another 6 is 22, plus 7 is 29, plus 9 is 38, plus 11 is 49. And if I divide that 49 by 7, I'm going to see 7 magazine subscriptions sold this week. Now, that same problem could have been done with a calculator, but generally, if you can do it in your head, go ahead. Either way, great job for sticking around until the end.